Covered today introduction Fossology, motivation, Fossology features, automation, how much automation is possible, and other tools in automations, and we'll conclude after that. So, what is Fossology? Fossology, the name as itself says, FOSS. FOSS means free and open source software, and ology means knowledge. So, Fossology actually gives you the knowledge of free and open source software. So, every great tool that is built, it built on a problem statement. What are the problem statement or the motivation behind building a tool like Fossology? So, we use open source software or any software. Any software comes with a license agreement or a legal notice, and the legal notice contains license involved in the software, copyright statement, authors, disclaimers, and much more stuff inside the legal statement. So, we need to find out this license statement, we need to find out the copyright, we need to find out authors from the OSS package or the files. So, it's license text, reference to licenses, a written text explaining licenses, and license relevant statements we need to find out. Many of the OSS projects are the consumer of the OSS. So, here is an example, a tool called Thrift, which is licensed under Apache. Apache licenses are mostly most homogeneous license. They usually declare it on the main license as the website. But if you scan one of this tool using Fossology, you will find along with Apache there are around 25 other licenses present in that tool. So, what is Fossology? Fossology is a web server application for license and copyright compliance of software component. The Fossology project is licensed under GPL2. 2015 Fossology project became a Linux collaboration project. It provides web server based interface and command line interfaces. It has different scanning agent to scan the OSS component. It's a multi-user, multi-tenant web UI to overview the job. And Fossology development stack, if we see, we have at the top layer the PHP web, and then in the middle logic is written in C, C++, and PHP, and database we use Postgres as a database. So, how does Fossology work? Fossology, whenever you get a OSS component, you can upload it to a Fossology. Fossology will unpack it. Then you can choose a set of scanners to run on the component. The scanners will run, the scanners will find the relevant text that is supposed to find by the scanner, and then it comes for a review and clearing process. So, once the scanner's findings are available with the Fossology web interface, then you can, the clearing expert or the people who has knowledge about licenses, they can go through the files and can review the findings of the scanner. And once they find the review, they can correct those review, and then they can generate a report which they can review it again whether everything is correct or not. There are a couple of license scanner in Fossology. So, I'd like to highlight here Nomos, Bulk, and Monk. So, Nomos is a regex license scanner. Then if we move to Monk, which is more complete text-based license scanner. So, precisions are more from left to right, but the flexibility reduces when it comes from Monk to Nomos. Fossology has a bulk scanner. What it does, Fossology, if the licenses are there in Fossology database, then it can able to find the licenses from the files. But if it is not, if it is not there, then also we need to capture those licenses somehow. So, if Fossology misses the licenses, then there is an option with the bulk feature where you can select that license, relevant text from a file, and can run it using bulk in your whole package. And means it will stamp all the files where you will get that license, relevant text. So, what are the new feature we have introduced from the last year? when we demonstrated Fossology here. SPDX import. SPDX is going to be a de facto standard for all kind of compliance stuff. So Fossology do support SPDX report importing. We do support SPDX report format. So a few challenges we face while importing a SPDX report, like how you handle the concluded license, how you create a candidate license for those to handle those new licenses, and if there is already concluded license in the package, then how to handle the SPDX report when you are importing a new license. You can stage them. So all this has been taken care with the SPDX import option. So this is a report import interface with Fossology, where you can choose the folder, then the package in the second line, then the SPDX report, and the license. You have a few options to choose the license as a candidate or a new license, then what are the information you want to include from the license, and finally you have to hit upload and import. So the report import will be uploaded, SPDX report will be uploaded and stamped to your package. So SPDX report import can also be used for reviewing your task, reviewing your other package. What I mean by this, for example, if you have uploaded already a package, if you have uploaded a package in Fossology, you have cleared that package. So that information is stored with Fossology. Now you have a new package, and the new package you want to upload, but you want to do a diff clearance with the new package. You want the old decision to be imported to with the new package. So you can do a diff clearance with report import. This is a new Word report that we have come up with. So usually reviewing XML file or SPDX file is very difficult. So what we did, we put those information into a Word report, so that you can generate a Word report, you get a complete clearing overview in a reporting format, that you can review it more easily. We have come up with an obligation policy management inbuilt with Fossology. Every company has their own license policy management around licenses. So what we did, we have a web interface now where you can add the obligations according to its risk topic, and we can map it with the license you want. One good thing about this, you can also import export the obligations into CSV format, and it makes job easier sometime to sync other server with your obligation policies. So now the biggest point today is automation, because due to this cloud era, the open source are more mainstream today. So what is the problem with automating the license compliance? If you see here, there are many licenses which are not being recorded yet. For example, here if you can see, I've given an example of Metrolink public license, then a Jabber open source license version. Those are not recorded. There are many custom license checks that need to be quoted. So here if you see, for example, this notice appear on all copies and supporting documents the name of Roaring Penguin Software Inc. And then you have some avoidable OSS critical, avoidable license also has OS critical license text. Like this firmware, this driver download into some card. And then the firmware is licensed to you strictly, firmware is licensed to you strictly for use in conjunction with the use of some adapter. So these are really blocking places where you can't do complete automation of doing this job. So now how we can do, we can analyze how we can do automation with Fossology. So for doing automation, we need a set of tools. Fossology provides you those set of tools. It has command line tools like CP2 Foss job, and license list, extractor. All these can be placed individually. You can run it. Different license scanner. individually, and then you can generate a SPDX output report. And the last thing is the REST API that's actually coming up. I'm hopeful that it will be done by this year end. So that resolve many of the automation problem. So is Fossology ready for automation? Yes, I'll say yes. With this tool set, we are ready for automations. We have scanner, command line tools, server, and you can use this tool individually to automate. You can get a XML or a SPDX report that again you can parse to a SPDX parser to analyze the report. So the below diagram shows actually the same thing where you can run the different agents in your daily CI/CD, and then you can parse the report to a analyzer and analyze it. But expert intervention is very much required, because with license clearing, means compliance stuff is without experts, it's very difficult to work on. So other automations approach, there are multiple automation approach with the compliance area, like OSS toolkit review. If you see those who try to do automations at build time, Quartermasters also does the same thing. But I took this due to a separate reason, though it don't do a complete automation, but they try to solve a real problem. The problem is the diversity of licenses. We have multiple licenses. The files stamped with licenses, those are unknown, or those are not known or not properly stamped. So what Clearly Defined tried to do, it's called crowdsourcing the clarification data from other OSS projects. So it works in 3 steps: harvest, curate, and contribute. What the harvest does, it can pull the data when you log into this Clearly Defined. It can pull the data from your login, for example, GitHub. It can pull the data and sync it with the Clearly Defined server. It will find the licenses. It uses Fossology scan code as a license scanner. It finds the licenses, then give it to you. You can verify, review it, which is curate. We can verify the licenses, and then you can contribute it. It's just a one click. There you can contribute back to the GitHub if the license is not correct. You can submit a pull request, and if it gets reviewed, and then it can be merged again, so that it gets corrected in the workflow itself. So this is Atarashi. This is a GSOC project. I'd like to invite Gaurav. He was an active contributor to this project, along with Aman Jain, who is not present here today. We got him to work on this Atarashi from part of GSOC. Gaurav.
Thank you. Okay. Yeah. So we started Atarashi as a new license scanner, which will ease you to make modifications. So if you are a user of Fossology, so you already know about Nomos. So what Nomos does, we have some set of rules, some regular expressions, which actually do the actual work. So if you come up with a new license, so in Nomos, what you have to do, you just have to change the source code of the Nomos itself, and you have to recompile it. So that reduces the flexibility of the tool. And if you take Monk, Monk does the full text scanning. So we have a full text of a license, which you rarely find in any source code. So that also does not solve the problem. So we came up with Atarashi, which use some text statics and information retrieval algorithms. So I have mentioned some of the algorithms here, like TF-IDF, DLD, Ngrams. So we use all those algorithms. So we prevent ourselves from doing a full text scan, and then it also uses basic formats like CSV and JSON as data source. So it also increases the flexibility of the tool. And we give you like 4 scanning algorithms and 4 different kind of similarity algorithms. So first, so this is the workflow of the tool. First you give any kind of file. So you gave it a source file. So we extract all the comments out of it, because the license relevant text or author relevant text you will find only in comments. And then we normalize the text. Then we do a SPDX header scan. So you people might be aware of the SPDX headers. So we perform those scans as a pre-scanning step, and then we move to different algorithms. So we give you choice of 4 algorithms. So out of those you can choose any one, and the results which are generated. So some of the time you may get some like maybe 5 or 6 matches for the same piece of code. Then we apply similarity algorithms to filter them out and rank them accordingly. And at the end you get the result in JSON format. So this is a workflow which I pick up for the n-gram algorithm alone. So after getting the normalized text, we also have a pre-processed license list, so which we use as our data source. Then we do a normal match on it using the basic n-gram algorithms, and then we find a similarity array. Along with the similarity array, we apply the similarity of these arrays onto the actual source file which we got, and then we rank the findings based on them. So n-grams give you a rank between 0 to 1. So 1 being 100% match and 0 being 0 match. And this is the data format which used by Atarashi. So this is a CSV format which we use for the first 2 algorithms, that is Demeru-Levenstein and word frequency. So as you can see, the actual data is in CSV format. So any time you want to add a new algorithm, a new license, you can simply just modify the CSV and it's there in your database. And we are using SPDX license list and SPDX exception list as our base. And on top of that, you can add your own license text. And these are the n-grams which we are creating from those licenses. So we are having an n-gram JSON and a license CSV. So you can see like there are some GPL, if you take the example of GPL license, the version 1, version 2, and 2 plus. So they have so much of similarity in them. So most of the scanners cannot identify whether it is actually version 1 or version 2 or version 2 plus. So we come up with a clustering algorithm. We cluster all the similar licenses based on their n-grams, and whenever you get a result, you get a cluster. Like suppose some text matches with GPL2, so you will get GPL 2.0 or later and GPL 2.0 as well. So I just show you a demo of Atarashi. So anyways, Atarashi is right now a CLI tool which takes a number of set of arguments, like we have segregated all the scanning algorithms as different agents, and we have all the similarity algorithms which you can apply. So if you want to scan a source code, suppose I take this file called as sample01 or maybe copyright.cc. So this is a text for GPL license version 2 header, and if I scan this using Atarashi and I'm using agent or the algorithm as n-gram with the similarity of bigram cosine similarity, and I just pass the name of the file. So it takes some time. Yeah. So I get the input file name, which file was scanned, and the complete result set as a JSON. So I'll just move towards the JSON schema which we are using. So this was the actual license test, and this is the output which was generated for n-gram algorithm using bigram cosine similarity. So yeah, you get the short name of the license which are standard by SPDX, then the similarity type. So if you are choosing bigram cosine similarity, you will get it there. If you are choosing cosine, normal cosine similarity, so just to identify which kind of similarity was applied, then the similarity score as scale from 0 to 1. And as you can see, like the scan output from the actual bigram cosine similarity is different, but we also have a header n-gram similarity. So this came up with our pre-processing scanning. So that actually gets the GPL 2.0 because this is just a header of a license. This is not the complete license. So this is a new thing which we have in our this Atarashi agent. And moving to TF-IDF. So like TF-IDF does not identify anything in this license header. So like still it is in alpha stage. So yeah, we are working on it to make it much more precise. And we are also following the SPDX standard header. So as you can see, this gives you a similarity score of 1. That is the 100% match for EPL 1.0 because this license header contains the SPDX identifier tag. So we do not need to look into the other results. Yeah. So I'll hand over back to Anupam.
Thank you, Gaurav. Thank you, Gaurav. So actually, I find this important. Why Atarashi is important because we try to move from a rule-based system to a statistical analyzer. So that's where most of the rule-based system, you know the problem around rule-based system. So this is finding with Atarashi you saw, and we are hopeful that it will be in the coming months. It will be integrated with Fossology and will be one of the main scanner in Fossology for license scanning. Oops. So now the conclusion, why the Fossology? Fossology offers you exactly what we require, that is license scanning, copyright, and keywords. It has high accuracy and low false positive. You can do delta clearing with Fossology. As I told earlier, that you can do difference of two package versions, and you can clear those, incorporating the changes of the other package in the newer version. And it suppose you can export different type of Word report, SPDX, and to review the Word format document we support. And most of all, what Fossology gives you, it gives you a review software inbuilt around with the command line toolkit. So it's help you in your review process. So that's a main USP of Fossology, using Fossology. So with this, I want to thank you all for attending this session. Here are the few links, important links. Fossology, then SW360. I didn't mention about the SW360 here. It will be the next session is we have another session for workshop. They will elaborate it, and then we have the Atarashi project, which is also open source now, and you can run Fossology just using a single Docker command, and it's coming up. So hope you to see there. Thank you all. Have any questions?
Question on how do you manage to find out the component content itself? So I understand Fossology uses SPDX licensing definitions,
Okay.
but what if licensing definition itself is not there, right? And if I use restrictive content in the source code, so how do you manage those kind of risks where your licensing content is not there?
See, if the licenses content is not there, and if you know the license has been found in some of the file, you can add that license as a candidate license with Fossology database. Okay, once you add it, then it will find it out for you.
That is, you'll have to have a proactive interactions with your developers. You have to know how they are using the content,
Yes.
make a local database, and then give the same information to your
Yes.
scanning engines.
First time you need to add this content.